Hi everyone, welcome to the session. My name is Srinivas, Assistant Professor of Physics. Now, today we are going to see what is linear momentum. Linear momentum. Linear momentum. For example, I'm assuming mass of a particle is small m. Small m is mass of a particle. Mass of a particle. And if it is moving, its velocity, we are assuming it is moving with velocity v. Velocity of particle. Then its momentum, its linear momentum can be written as P equal to whose mass, product of mass and its velocity, m into v is the momentum of a particle. Now, as we know that the rate of change of momentum is called force, then the external force acting on the body can be written as F external. F external equal to rate of change of momentum dP by dt. Rate of change of momentum dP by dt. So that equal to, let us substitute P value in this equation where P is momentum and mv. Let us take m. M is a constant. Now let us take m common, then we'll get dV by dt. So what is dV by dt? Rate of change of velocity. Rate of change of velocity is nothing but acceleration. Then F external. F external is what we get there, substitute where A is equal to dV by dt. So if you substitute, we get F is equal to ma. This is what Newton's second law. Now the force acting on the body is in the direction. The moment is in the direction of momentum of the body is along the direction of the force. Now, let us see linear momentum of system of particles. Previous case have seen momentum of a particle. Now, the linear momentum of system of particles. Now, let us assume a system which contains n number of particles. Let us consider a system which contains n number of particles. N number of particles. N number of particles which contain. Now, its masses of the particles can be taken as like this: m1, m2, m3 up to mn, whose masses. And also, then the velocities of the particles can be taken as v1, v2, v3 up to vn. Now, the total momentum of the system, can be written as P bar equal to momentum of individual particles. Momentum of individual particles. Total momentum of all individual particles. See, how can we take m1 v1 momentum of first particle plus m2 v2 momentum of second particle and m3 v3 momentum of third particle and up to mn vn momentum of nth particle. So this is the total momentum of system of particles. But as we know that according to law of center of mass, total linear momentum of the system is equal to the linear momentum of center of mass. See that total linear momentum of the system is equal to linear momentum of center of mass of system. In that case, we'll write P bar equal to capital M, mass of the system. Capital M is nothing but mass of the system, and where we can write total velocity or velocity of center of mass can be written as VCM. VCM. That is the velocity of center of mass. That is the velocity of center of mass. Then the total linear momentum of system is equal to the linear momentum of center of mass of system. So that can be written as P bar is equal to M into VCM bar. Now rate of change of momentum. Let us take rate of change of momentum. This is the total momentum of the system. Now the rate of change of momentum is nothing but force, external force, dV bar by dt. So that can be M is constant term and dVcm bar by dt. So where we can write that is equal to F external force. Now F external force is equal so dP bar by dt, dP bar by dt, dP bar by dt. So this is the linear momentum of system of particles. What is F represents? F is nothing but external force acting on the system of particles. Acting on the system of particles. Next our topic is conservation of linear momentum. See, just now I have seen external force acting on the body system of particles can be F external is equal to dP bar by dt, dP bar by dt. Now, if no external force is acting on the system, if there is no external force acting on the system, so then what happened? F external equal to 0. Then what happened? dP bar by dt equal to 0. From this equation we will get P bar equal to constant. P bar equal to constant. Now what we can say, if there is no external force acting on the system of particles, the total linear momentum of the system of particles remains constant, which implies the conservation of linear momentum, If the momentum is constant, if the momentum of system is constant, then we can, which implies that conservation of linear momentum is constant. Now our topic is variable mass system. See here, we all know that mass is constant. So according to classical mechanics, the mass of the system is always constant, right? Mass of the system is always constant. According to classical mechanics, mass of a system is always constant. Such type of system where the mass is always constant, such type of systems are called isolated systems. In which mass of a system is always constant. But there are few systems whose mass continuously varies over a period of time. This system are called variable mass systems. Systems in which mass is varied continuously over a period of time. So such systems are called variable mass systems. Now, example for variable mass system is motion of the rocket. So we all know that most of the mass of a rocket is its fuel, right? So if we take a rocket here, so most of the mass placed in the form of fuel, which is placed in the chamber, right? Which is placed in this chamber. So as we know that when the fuel is burning and the combustion gases coming out through the nozzle with high pressure. Coming out through the nozzle with high pressure. So as a result, what happened? The velocity of that escaping gases is more and more. As a result, they import some momentum to the rocket to move forward direction, to move upwards direction, right? So when the fuel burns, what happens? Then the burning fuel produces combustion gases. That gases comes out through the nozzle from here with high pressure. As a result, they import momentum to the rocket and the rocket moves in the forward direction, right? This is so happen generally in the motion of rocket. So but what we are doing, what happened, what we are discussing variable mass system. We are talking about variable mass system. When the rocket moves upwards direction, when the gases are coming downwards direction, what happens? Its mass slowly decreases. Its mass slowly decreases. Let us see here. Let us assume at a time t, at a time t period, at a time t, momentum of the system, what we are initially momentum of the total system can be taken as Pi equal to Pi, otherwise P1 equal to initial momentum of the system at a time t, can be written as capital M, mass of total system, and the velocity of the system. System is nothing but rocket here. Velocity of the rocket, right? P1 is equal to mv bar. Now, so after certain time, let us assume at a time t plus delta t, the total momentum of the system. Total momentum. In meantime, what happened? In meantime, fuel burns and some gases are escaping from the nozzle. So in t plus delta t time, so total momentum of the system can be taken as P2 equal as the time increases, what happens? Whose mass decreases. The amount of mass decrease, it can be m minus delta m. What happened? Velocity increases. The increased velocity v2 v plus delta v. Okay, and plus what we are talking about total mass, total momentum of the system at a time t plus delta t. Therefore, system is nothing but rocket as well as gases. So here, now let us take momentum of the gas also considerable. So delta m into u bar. U bar is what? Velocity of gases. U bar is nothing but velocity of gases. And we know that the external force acting on the rocket, can be taken as delta p bar by delta t, rate of change of momentum, change in momentum by time. So delta p bar by delta t. Let us substitute. Delta p bar can be written as how much? How can we write this one? P2 minus P1. P2 minus P1 by delta t. Right, P2 minus P1 by delta t. Now substitute P2, P1 values in this equation. See what we get if we substituting these two equations in this equation. Assume this is equation 1 and 2. This is what 3. Substitute 2 and 1 in 3. So substituting in this equation, what we get there? So F external is equal to P2. What is P2? m minus delta m v bar plus delta v bar and plus delta m into u bar and minus m u bar and minus m v bar, initial momentum, final momentum minus initial momentum by delta t. Now let us separate the terms here. F external equal to F external is equal to, so multiply inside, then what we get there, m v bar by delta t, m v bar by delta t. Again what we get there, m delta v bar by delta t. So again multiply minus delta m v bar by delta t and minus delta m delta v bar by delta t and plus delta m u bar by delta t and minus m v bar by delta t. So what happened here? Two terms cancelled each other. This one cancelled, and finally we have the term here m delta v bar by delta t and plus here we have to take delta m by delta t common, delta m by delta t common, and what we have the term, next term is what, and u bar minus v bar plus delta v bar. Right, so we got this one. But we know that delta m is mass of gases. Now what happened here? Mass of gases are moving downwards direction, and that is decreased mass, right? Delta m is nothing but decreased mass. Now delta m can be taken as minus delta m. Substitute in the equation, and what we get there, m into delta v bar by delta t and minus delta m by delta t into u bar minus v bar plus delta v bar. And let us rub this term, and again we consider here one more thing. If delta tends to 0, what happened here? Delta v tends to 0, and using these two conditions, what happened? The equation changed into like this: m into dv bar by dt, m into dv bar by dt minus, here we will write dm by dt, dm by dt, right? dm by dt, capital M, you have to take capital M always, dm by dt into what we get there, u bar, where delta v tends to 0, then u bar minus v bar, u bar minus v bar. So finally from this equation, what do we get there? From this equation, change in momentum can be written as change in momentum. Otherwise this one also be written as, here see how to write this one. So F external equal to m dv bar by dt, so minus dm into u bar by dt and plus v bar into dm by dt. This can also be written as F external is equal to d by dt into mv bar minus u bar into dm by dt, minus u bar into dm by dt. So this term represents Newton's equation of motion for the variable mass system. Newton's equation of motion for variable mass system. This equation represents Newton's equation of motion for variable mass system. F external is equal to d by dt of mv minus u bar into dm by dt, minus u bar into dm by dt. For example, mass of the system is constant. Mass of the system. Now let us see it satisfies Newton's second law or not. See there, if mass of the system is constant, what happens? If mass of the system is constant, right? Mass of the system m is constant. Therefore, what will happen? dm by dt equal to 0. Substituting in that equation, then what we get? F external is equal to some m into dv bar by dt, and the remaining term goes to 0. We'll get ma. So F external is equal to ma bar. So next thing is, this is known as well-known equation, Newton's second law. F external force acting on rocket is what? F external is equal to ma. Now let us see here one more thing. So from this equation here, see there, change in momentum. How can we write change in momentum? This equation can also be is the instantaneous force acting on the rocket. See there, m dv bar by dt equal to F external. From this equation I am writing mv bar by dt equal to F external, and you send this term this side, and what we get there? Plus we get there u bar minus v bar into dm by dt, right? dm by dt. So this can also be written as m into dv bar by dt, and this can be written as F external plus u relative velocity. U relative is nothing but relative velocity, relative into dm by dt, right? Next, where m into dv by dt is the instantaneous force acting on the rocket. This term, instantaneous force acting on the rocket, F instantaneous, where see here, so this term is also called reaction force. It's also called reaction force, F reaction. So from these equation m into dv bar by dt, so that is equal to F external force plus F reaction. So the instantaneous force acting on the rocket is equal to addition of external force plus and the reaction force that is due to the escaping gases. So this is the resultant equation. This is the resultant equation for variable mass system. So that is for the motion of rocket. Okay. So this is all about variable mass system.